Now you should know what are the typical use cases of containerization, specifically Docker, how to work with Docker, especially with data exchange. But now, before we continue to Kubernetes, it's good to know some technology behind Docker, specifically because of the security of IT systems. So, what's gonna happen when you build a new image with Docker file? So, as you remember, you type in your command line interface command docker build --t my app space dot, which reads a local Docker file, yes, and so you ask the Docker to build the image from files in the current directory. And then Docker command line interface sends the content of this local directory pointed with dot to the daemon. You need to have your Docker app running in the background. Docker pulls the Alpine image. If the Alpine is in your first line, you may have obviously some other light Linux distributions, yes, from the registry, for example, from Docker Hub, yes. So imagine that this is the local file, and the first line is Alpine, next you have Jupyter, next you have your notebook, app.ipynb, yes. So this is the simple sequence, but obviously in the reverse order. Next, then creates new images by adding layers one on top the other. As you can see, this is the next app. Then run Jupyter, which is the final command in your sample Docker file. Yeah. So maybe you have already observed that if you just simply slightly change the Docker and the other layers are already there, Docker itself is smart enough to skip those layers. It'll tell you, okay, they exist. It's just not to repeat the now load process, etc., etc., etc. So it's built layer by layer by Docker daemon. So here we have the command to run as a final layer. And then when you run your container in your host, whether it's a local machine or some remote machine, on macOS or Windows, Docker installs and runs container within a Linux virtual machine. On Linux, it's not needed, yes, because it is Linux itself. So this is your computer here, yeah, and this is the Linux virtual machine, just only for Mac and Windows. Jupyter processes those processes which we had in our sample Docker file run within such a container. Yeah. Jupyter listens on port 8080 of the container. Obviously, it's if it's specified, but this is the default port. But on the other hand, our virtual Linux machine communicates with the world on the port 10,000. So we need to map in our Docker run command the port 10,000 of the Linux virtual machine forwarded to the containers port 8020. So this is the rationale behind sometimes you need to run Docker container with specifying forwarding. We need to specify forwarding. So this is the reason why, yes. And before we continue, in the context of the security, it's good to recall a concept of Linux namespaces. So I strongly encourage you to read some brief introduction to this concept. You can also ask ChatGPT for that. But the most important namespaces in Linux are the mount namespace, which isolates mount points, file systems. The process ID namespace, PID, which isolates process IDs. The network namespace, NET, isolates network devices, stacks, ports, etc., and the user ID namespace, user, which isolates user and group IDs, and C group namespace, which isolates the control group's root directory. So recall that. Because the processes which run in your computer can share such namespaces. Can share, and it is heavily used in Docker images. So using these mechanisms, containers can share image layers. So you have a host operating system which runs different containers with different apps. This is app 1, this is app 2, this is app 3. They can run, container is a running app, but they may share files between containers. Remember probably this volume mount, yeah. But moreover, if they can share libraries and files between containers, yes, depending obviously on the command, docker run command and the docker file. So this is very good, but on the other hand, why? Because we simply save our resources, but on the other hand, maybe the source of some security issues. So when you compare, for example, virtual machines with containers, containers definitely consume less resources. There are no guest operating system. Yeah, so obviously it's very good for computing resources, but because if you use virtual machine approach, each virtual machine runs with the guest OS, yeah, and they are logically separated. So there is no risk, almost no risk, that there will be a kind of the data leak or kind of the influence from the virtual machine one to the second one. But that may be, due to sharing, be a danger in containers. Specifically because we can share kernels. Yes, so as you can see, we have in virtual machines a hardware, kind of the hypervisor structure, and for each virtual machine we have a virtual hardware, virtual kernel. Yes, so these are completely separate machines. In that sense, they are more secure. Sharing the kernel here between containers may be dangerous. That your containers may be prone to different types of attacks, vulnerabilities. By the way, for example, GCP, Google Computing Platform, when you upload your Docker image to the artifact repository, it will automatically, you may enable, but this is the default option, enable the option of vulnerability scan, and you will get a very interesting report with different types of vulnerabilities, many times hundreds of them on the different priority. So you can also make a kind of the sanity check using the external services for that. So that's probably the reason why people who are responsible for IT security, safety, do not like, in many cases, Docker as the environment. So Linux namespaces ensure that each process has its own view of the system, so it can see only some of the files, processes, and networks. So we can use this mechanism to control the safety. So that completes a very, very basic introduction to the concept, technology behind the Docker. Obviously, this is a very, very long story, and I think that now you're ready to go into the basics of Kubernetes. Thank you.